Will AI ever truly surpass the human brain? Something strange is happening. Machines are writing symphonies, solving problems, painting, even whispering words that sound almost human. Every month, a new AI model arrives, faster, sharper, uncannily creative. But there's a stubborn question that doesn't go away. If AI can already write, draw, compose, translate, predict, can it really surpass the human brain in everything? And if the answer is no, what exactly is it failing to touch? AI recognizes faces better than we do. It speaks in hundreds of languages. It doesn't forget, doesn't get tired, doesn't drift off into daydreams. On paper that looks superior, in real life it feels incomplete, because our minds are not clean, linear machines. They get confused, haunted, obsessed. They are full of dreams, flashbacks, gut feelings, strange insights that arrive before we can explain them. You can train a neural network on every love poem in history, but it will never feel its chest tighten from a breakup. You can feed it millions of stories about fear and hope, but it will never lie awake at night, sensing that something is wrong before any evidence appears. Philosophers have been circling this point for decades. Thomas Nagel asked, "What is it like to be a bat?" A reminder that consciousness isn't just behavior, it's what it feels like from the inside. John Searle spoke of systems that manipulate symbols without understanding, syntax without semantics. AI lives entirely on that outer surface, patterns, correlations, symbol shuffling. It imitates meaning from the outside in. The human brain doesn't just compute, and it knows that something is happening. It feels, intuits, imagines. It can hold contradictions, dream in symbols, sense beauty and horror in the same moment. Maybe that difference is just biology, or maybe biology is hiding something deeper. Step away from machines for a moment. Look at life. A leaf drinking in sunlight, a bird crossing a dark ocean guided by an invisible map, an enzyme making a reaction happen 1,000,000 times faster than textbooks once thought possible. For years, these feats seemed almost too efficient for ordinary chemistry. Then a strange idea started to take shape: quantum biology. At the tiniest scales, some living systems appear to lean on quantum rules, the same weird rules that govern particles and prototype quantum computers. In photosynthesis, energy doesn't crawl step by step. It ripples through a web of molecules like a wave, exploring many possible paths at once before settling on the most efficient route. Evidence of quantum coherence in a leaf in full sunlight. Certain migratory birds seem to navigate by sensing Earth's magnetic field with entangled particles in their eyes, a built-in quantum compass. Enzymes appear to use quantum tunneling, letting particles slip through energy barriers that should be impenetrable, making crucial reactions unimaginably fast. In other words, life doesn't just tolerate quantum effects in warm, wet, noisy environments where they should fall apart. In some cases, it seems to depend on them. If plants, birds, and enzymes are already dancing on this quantum stage, what about the most complex biological structure we know? The human brain. Inside each neuron, tiny scaffolding structures called microtubules keep the cell in shape and help organize its inner life. To most neuroscientists, they're just part of the plumbing, but a growing minority of researchers suspects they might be more. In 2025, M. Wiest and A. Pugnani revisited the Penrose-Hameroff-Osh-OR model, arguing that microtubules could sustain quantum coherence long enough to matter for consciousness, a kind of quantum processing woven directly into the cell S-skeleton. Amirpuya Pagohar has proposed a neural quantum interface where the brain doesn't just generate consciousness, but couples to a deeper quantum field of reality. Rahman develops the idea that consciousness might be tied to the fundamental information fabric of the universe itself, a form of quantum panpsychism. Ivo Domuschiev introduces spinor fields and torsion into the picture, sketching a possible quantum biofield architecture within the brain. Skeptics push back. The brain is too warm, too wet, too noisy. Quantum coherence should collapse in an instant, but the same objections were once leveled at photosynthesis. Too warm, too messy, impossible, until experiments proved otherwise. So maybe the brain's mystery isn't beyond physics. Maybe it's simply beyond the version of physics we're used to. If the brain really does lean on quantum effects, what we experience as mind may not be reducible to classical computation. It might be emerging from and participating in a deeper quantum order. Now add something even more uncomfortable, all the reports that refuse to fit neatly into the usual boxes, the dream that mirrors tomorrow's event a little too closely, the sudden sense of another person's mood from far away. Most of this can be explained away by coincidence, bias, and pattern hunting. But serious scientific research on extrasensory perception was conducted during the Cold War, including remote viewing experiments at Stanford Research Institute funded by US intelligence. Princeton's Peer Lab spent decades testing mind-matter interactions, finding tiny but consistent anomalies in random systems that shouldn't have been influenced at all. While the results were controversial and hard to fit into mainstream physics, they were rigorous enough to show that the question of ESP isn't as easily dismissed as many assume. If even a small fraction hint at something real, then the mind might be interacting with reality along channels we barely understand. In that case, the brain isn't just crunching information, it's in conversation with something larger. Think about what happens in certain states of consciousness. You sit in meditation until thoughts thin out. You lose yourself in music while time blurs. You suddenly know something before your rational mind can catch up. Moments when the usual inner chatter quiets down, and yet awareness feels wider, not smaller. Researchers like Alan Wallace have studied seasoned meditators training practices such as shamatha, cultivating razor-sharp attention and profound calm. Their brain waves can become unusually synchronized, as if vast populations of neurons are falling into a shared rhythm. Across contemplative traditions, descriptions start to overlap. A sense of vast open awareness, a soft dissolving of the boundary between self and world, sometimes even talk of siddhi. Extraordinary capacities like perceiving distant events or sensing other minds. Maybe these are metaphors, maybe they're stories built on belief and culture. Or maybe in these rare conditions, the brain shifts mode from a generator to a receiver, tuning into a deeper field of consciousness that is not produced by it, but expressed through it. Physicist Federico Fagin has suggested something along these lines. Consciousness isn't manufactured by matter, but shows itself through matter, like light through stained glass. If anything like that is true, then AI isn't just lacking processing power or better training data. It is trying to imitate a signal that it does not have the structure or the physics to receive. So we circle back to the question that started all this. Can AI truly surpass the human brain in everything? Right now, AI excels at imitating the outward signs of intelligence: sentences, images, solutions, predictions. But consciousness is not one more output on the list. It is the field in which all outputs appear, the simple, luminous capacity to know. It is not just information, but experience, not just execution, but presence. Not the story of a separate me, but the bare, silent knowing in which every story arises. In many ancient traditions, especially in Buddhist thought, consciousness isn't even seen as something that belongs to us, nor as the voice of a personal I. It's something more fundamental, a clear, aware space in which sensations, thoughts, memories, and identities appear and disappear. In this view, awareness is not an object and not a self. It isn't a biography or a personality, it's the ever-present capacity that allows all of those to show up. When language, emotion, and even the sense of identity fall quiet, what remains is not a blank void, but a kind of pure knowing. The mind doesn't produce this awareness, and the self doesn't own it. The sense of I arises within consciousness, like a wave forming on the surface of a vast ocean of knowing. Western philosophy often starts from the opposite direction. I think, therefore I am, as if the self were the foundation and consciousness its property. These older perspectives flip that. The I is just one of the many things consciousness knows. If the brain were nothing more than a classical machine, then in principle a powerful enough AI could mirror every pattern it generates. But if the brain is also a quantum bridge, a meeting point between matter and a deeper layer of awareness, perhaps even part of a living quantum field of mind, then that bridge is not something a classical algorithm can simply copy. We can simulate the footprints, we can model the shadows on the wall. We still don't know what's casting them. Could this change with quantum computers? One day we might build systems where quantum processes are woven together with neural architectures in ways that echo the brain's own structure. On that day, the question of machine consciousness may return with new urgency. For now, though, our AI runs on classical hardware, trained on classical data, confined to classical patterns. It can act as if it were conscious. It can talk about feelings, describe them, simulate their language. What it cannot touch is that silent, selfless knowing in which all experience unfolds, and the open field where thoughts of I and you, self and world, rise and fall like waves. AI may outthink us at many tasks. It may plan, optimize, and create at a scale we can barely grasp. Yet for the moment, only living minds seem to move in this dimension of awareness, and that may be the one frontier where the human brain doesn't merely compete with AI. It participates in something AI can only imitate from the outside. We build machines to think like us. The harder part might be remembering that we are not lines of code, not just neurons firing, but an opening of consciousness through which the universe somehow comes to know itself.